Okay. Hi everybody. Today I wanna solve this problem about building boxes. So let's start. Um, so the problem is about finding the efficient way how we can uh, place boxes and boxes in n by n by n uh, size room. And the idea there is that um, the boxes can be stacked on top of each other only if um, there is like a there is a base for the box that goes up. So like box one box can be stuck on other box unless there are like left and right, like north, south, uh, east, and west boxes, or if there is a wall next to that box. So this box doesn't need the northwest box and north, like doesn't need the west box and north box because or like if you look at this, like north, west and southwest boxes, because this is staying next to the wall. That's why it doesn't need that to support the higher box, but it still needs it here and here because there is no walls like there. So it must be adjacent to the another box or wall, and I should return the minimum possible number of boxes touching the floor. So it's kind of situation when we put like when we add the boxes from top and they scatter around like uh, unless they form like until they form a kind of mountain, and we should actually calculate the base of this mountain, like what the area is gonna be occupied with these boxes. So let's me show you. So this one task, um, okay, so I also should talk about n. So n is 10 to the power of 9, and this is already like more than computers can calculate if you have of n algorithm. So I should come up with a better than of n algorithm, and like adding every box like on every iteration will not work. So it should be like I should do that faster, and I already kind of thought about this problem, and by I can start by just having this. Let's say this is a corner of our room. This is V, X, and Y, and I can like build boxes in a way that kind of try to build boxes in a way that fit under this triangle. Um, so let's say the first iteration gonna be triangle of size 1, 1, 1, one box. So it's gonna be uh, basically this box. Mm. And then I'll keep expanding this triangle, and I'll keep counting the number of boxes under this triangle. So if I expand it like further, I'll have this box like this, then here and stay in here, and then on the one on top of it. Let's use different color to make it more obvious. Um, yeah, and then I'll keep expanding. So like on the first level I have one box. On the second level I'm gonna have uh, like one box from here plus three boxes. On a third level I'm gonna have four boxes plus uh, plus one box plus. So this one was one plus two, and this is gonna be four boxes traveled from the previous level plus one plus two plus three. So it's gonna be uh, the 10 boxes. Why is this happens? So I need to count the number of boxes that's gonna cover the previous number of boxes. So it's gonna be like the same kind of boxes, number of boxes shift up to cover like a previous one. Like, so we have like one on the top, one, two on the second level, and then one, two, three on the third level. So it's kind of like if this is a box on the first level, then to cover this box on like when we grow this triangle, so it's gonna we need like one and two boxes on a second level, and uh, if we grow it even further, on the third level we're gonna need three boxes, and I also need to add the previous levels. So it's gonna be like this formula, and I'm gonna incrementally start building these triangles and check if the current number of boxes under the triangle is uh, greater than n. And if it's greater than n, it means that I need to go to the previous level and use it as a base for further like checking the number of boxes that we need to add. Um, this trick will help me to get rid of this 10 to the 9 complexity, because every time you see that the growth is kind of, I know, it seems like faster than O of n. I'm not sure if it's like, so we add, so f of n, let's say f of uh, 1 equal 1, f of 2 equal actually f of 1 plus 1 plus 2, f of 3 equal f of 2 plus 1 plus 2 plus 3. So it's like, since the formula is following, f of n is equal f of n minus 1 plus sum uh, I from 1 to n, and then I, sum of I. So it grows like, I assume it's like exponential growth here. Um, so if we count the delta divided by 1 equal sum of I from n to I, from I to n. Um, So delta equals the sum, and it means that delta is increasing, and like increasing like not with the constant factor, with the factor that depends on the n. And if we do this, it's gonna be n minus 1, n plus 1, no, by n over 2, something like that. So the growth factor gonna be, so the like f delta of x gonna be x squared, something like that. And if f delta of the x, then fx grows with like uh, grows equals like n cube. So the growth is n cube. That means that the complexity gonna be uh, so we are kind of calculating every time we are calculating it with a faster rate. So it's definitely not of it's not like linear as time complexity for this algorithm. I need to think how I can like yeah, how to transfer from like this exact formula to actually what's the time complexity of calculating this formula. So like time complexity, yeah, ignore that. Time complexity is uh so n here is actually the input size, yeah. And because it grows like with the rate n grow like f of n grows with the rate of n cube, it means that like we calculate the first one, the output is gonna be like 1. We calculate the like so like yeah. I guess the tangle complexity, even if I use this recurrence formula for calculating n, is not gonna be like of n, something like that. So yeah, so that's how I calculate the first part. The second part gonna be something like, so we already know the let's say we have this um, kind of boxes. This is like stacked against the wall. This is x, y, z. Let's say we have like these boxes. One box, two boxes, say. Then let's build another layer and then I'll start explaining. So on the first we had one box. On the second we have um, after we add on top of that we have 4 boxes. Third, when we add the third layer we have totally um, 4 plus 4 plus 1 plus 2 plus 3, 10 boxes, and say our n is equal, let's say 14. So let's check if we have on the third layer 10 boxes. And one here. So these boxes, and we count how many we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 boxes, and but we need to add more. Like we need to add 4 more boxes and calculate the area. When we add 10 boxes, the area gonna be 1, 2, 3, 4, 5, 6. Area now is 6 area, but we need to add 4 more boxes. So my argument here is that um, I need to start adding, like the most efficient strategy is start adding boxes of starting from the like one of the walls. Let's say we add one box here, and by adding one box we added +1 to the area because we added like it on right on the bottom, and then we have like now 11 boxes total, this on the area, so 7. And next boxes I want to add adjacent to that one. So like if I add another box, I cannot add it here because it will not, there is no box in this space to support the second layer. So I need to start adding boxes adjacent, so like here, and as soon as I add here box, so we have like +1 area, so then +1, so 8, and then here are gonna be 12 boxes. And then in order to add another one, um, I'll add this one on top because now I can do that. And then this it will not change the area this pile of boxes uh, uh, occupies, but I still change the number of total boxes. So it's going to be +1, 13, +1 box here, and then I need to start adding again one box because I have total 13 boxes, but I need actually 14. So I'll start adding like one box here. Yep, and there's gonna be +1 here, 14, and +1 here. Uh, okay, +1 equals 14 here, total boxes, and +1 2008 is going to be 9. So the area occupied by 14 boxes is going to be 9 units. Um, and this one, like if let's say we wanna have not 14, but let's say we wanna have, um, what is happening here? Let's say we wanna have like 17. So we need to continue adding boxes. So it was here. So the last box we added here. Then so I continue adding boxes on. Yeah, continue adding boxes. One was here, the second was added here. So now I have like +2 boxes in total, but I haven't used additional area. And in order to make it 17, I need to go further one level and like start adding boxes here. and then continue adding boxes on top of that one. And then this is +2. Oh, like just one box. Let's say when I have 18, I just added 2 boxes here. So the area for the 18 boxes is gonna be like 10 because we added one more box here. So it's always like I add boxes like uh, when I calculated the closest triangles, I start adding like one by one box, and then like add on top of like 2 boxes, and add of top like 3 boxes, and add of top on top of that 4 boxes. And every time I add like this kind of stripes of boxes, I start occupying +1 uh, unit of area, because every stripe here I add, it just occupies 1 unit of area, like this one. Yeah, so here was +1, here was +1, +1, +1, but the number of boxes I'm adding, like here I added like +1 box, here I added +2 boxes, here I added +3 boxes, and here I added +4 boxes. So this is gonna be the algorithm. First, so the step number one is calculate the max total boxes under triangle, and second one, add stripes of boxes so n can be adjusted precisely. Yeah, so that's gonna be the algorithm for this access for this problem. Let me start coding it. So initially I need to go int, let's say I have like variable total boxes. Equals, let's say I'll start with 1. Int prev boxes equals 1, and then int uh, previous delta int prev on floor delta equals 1. So now what I'll do while total boxes less than n, less or equal n, I'll do the following. I'll add int boxes int on floor delta equals +1, and then int delta equals prev delta plus on floor delta, and then prev boxes equals total boxes, and then total boxes plus equal delta, and then prev delta equals delta, and prev on floor delta equals on floor delta. So this will give me like maximum triangle, and this is the triangle. Say total boxes. I'm gonna reassign total boxes to the prev, and then I need to calculate also int on floor boxes equals 1, int prev on floor boxes equals 1, and then on floor boxes equals on floor boxes, and then on floor boxes gonna be plus equal on floor delta. Total boxes equals prev boxes prev total, and then prev on floor boxes equals prev on floor boxes. So like current number is exceeding n of total boxes under the triangle, so I need to go to the previous total boxes under triangle under less kind of under lesser triangle, and also I want to calculate the height equals 1 initial, and then on every iteration I'll get plus plus do the height plus plus, and then I need to go while total boxes less than n, I add, let's say, int delta equals 1, I add on floor boxes. So this one is gonna be the actually the one that when I add the stripe of boxes. So on every iteration I add one on the of the floor, and I add like one like previous number of boxes I added plus 1 to the total number of boxes. Int delta equals 1 on floor boxes plus plus, and then total boxes plus equal delta, and then after that I'll add delta plus plus, and then in the end I need to return total boxes. No, return on floor boxes. So that should be it. Let me count. I don't even need to save the height like this. Yep, that should be it. A bit over like, well, I've been following that for 29 minutes, but I guess that's worth it. It was worth it. Um, so the time complexity. So Leetcode suggests me that it's like all fan time complexity, but actually it's not. because if it would be of n time complexity for the n equal um, for the n equal 10 to the power of 9, it will complete like within seconds. So it's definitely not O of n complexity here. And like the growth, how we add uh, delta to total boxes. So delta, like, it's not a constant growth. So it's, I guess it's exponential growth. So yeah, that's it.